Welcome to Biology My Passion. I am Soumya Harikrishna. We started the chapter Chemical Reactions and Equations, first chapter in class 10. In the previous video, we learned how to balance a chemical equation. Today, we will start with the different types of chemical reactions. So, we learned any chemical change is accompanied by a chemical reaction. So, there are different types of chemical reactions occurring around us. They are categorized into 5 stages. So, if these 5 types you learn with their examples, then the chapter is done. So, first thing you have to by heart the types of reactions. In the order itself you by heart, then it will be very easy for you. First is a combination reaction. Second, decomposition reaction. Third, displacement reaction, or we call it a single displacement reaction. 4, double displacement reaction. 5, oxidation and reduction reaction, otherwise called a redox reactions. Once again, combination, decomposition, displacement, double displacement and oxidation and reduction reactions. Now we will see one by one in detail. Let's start with the first reaction, that is combination reaction. From the name itself, combination, combining. So 2 or more reactants can combine. Okay? And how many products we get? A single product we get. So we know that reactants are written on the left hand side of the equation and the product is written on the right hand side of the equation. So whenever you look at this equation, you will find more reactants. They are connected by plus sign on the left hand side, but right hand side of the equation you will see only one product. So if you see a reaction like this, immediately you can say that it is combination reaction. For example, if A is a reactant and B is another reactant, then they combine to form a single product AB. Suppose more than 2, A plus B plus C, 3 reactants are there, A, B and C. Then what is the product? ABC, combining to form a single product. So always see left hand side reactants more, but right hand side only one. Then such reactions are called a combination reactions. Now, what can combine during a combination reactions? So the reactants may be 2 or more elements only. So in some reactions like carbon and oxygen combine to form carbon dioxide. So both are elements. So like that it can be between 2 elements or between 2 or more compounds also it can happen. Or for example, we will study one example, calcium oxide combines with water to form calcium hydroxide. So there actually compounds are combining to form product. Sometimes it can be between elements and compounds. So there can be different types of combination of these species of substances in combination reactions. Now we will see the examples of these combination reactions. The first example given in NCERT is very important in terms of examination point of view. So first we are adding calcium oxide. Calcium oxide is otherwise called a quicklime. Now itself you have to learn the other name also. By heart it along with me. Calcium oxide. Calcium oxide. What is the formula? Calcium oxide. I'll write the equation after this explanation. So CaO, calcium oxide, we have to take maybe 2 to 3 grams in a small beaker. To that we have to add little bit of water. So when we add water, you can see a highly vigorous reaction is happening between these two. And heat also will be coming out. Then what is the product form? We get a kind of solution called a calcium hydroxide. So you can see calcium oxide where calcium and oxygen only there, but here calcium hydroxide, hydrogen also came. So this is called slaked lime. So remember, calcium oxide is quicklime. When it is mixing with water, it becomes slaked lime or calcium hydroxide. So along with that, what is also liberated? Heat is also liberated. So the reactions in which heat is liberated out are called what? The exothermic reactions. Now we will try to write the equation. Calcium oxide. Calcium is Ca and oxygen is O. Both are having valency 2. So we write CaO. Quicklime plus water. H2O. Water. So quicklime is taken in solid form. Water is the liquid form. And what do we get? Calcium hydroxide CaOH twice plus heat will be liberated out. Okay. So this calcium hydroxide we are getting as aqueous form. Now one more part of this equation is very important. So you understood the equation CaO calcium oxide quicklime. combines with the water to form calcium hydroxide or silicate lime and heat. Why it is OH twice? Because OH is 1, calcium is 2. So when we do the equation, it will be like this. So it is an aqueous. Aqueous, we learned that it is a solution in water. So this solution has got a very significant use in the daily life. But nowadays we are not using, but long back people used to use this for whitewashing purposes. See, nowadays we get the paints of different types, like emulsions are there and different categories that can resist all the environmental stresses and all. But in olden days, people would use only white, this silicate lime solution to apply on the walls. Okay, so once we prepare this, this can be applied on the walls as a coating or like a paint. But initially you will not find much white color or brightness or anything, but you leave it for 2-3 days. After 2-3 days you will see that the wall has become whitish in appearance with a kind of shining surface. Not very shining, but like emulsion, but shining surface is there. So this is called what? Whitewashing, which is the use of this calcium hydroxide or silicate lime. How is this happening? How is it turning white after 2-3 days? When we apply this calcium hydroxide on the walls, the atmosphere air is there. Air has got carbon dioxide in it. So the carbon dioxide reacts with this aqueous solution of calcium hydroxide applied on the wall. Okay, as a result, a kind of white color deposit will be forming, that is of calcium carbonate. So calcium carbonate is nothing but marble or chalk or limestone. All these are basically calcium carbonate. So because of the presence of that deposit of calcium carbonate, the wall is turning whitish in appearance. Okay, so we will write the equation of that also. So calcium hydroxide applied on the wall reacts with the carbon dioxide. So what will we get? Calcium carbonate and water will be released out. So here calcium hydroxide we applied aqueous, carbon dioxide is a gas, this is a solid and this is a liquid. So this is a formation of calcium carbonate if asked. So here calcium hydroxide of silicate lime combines with the carbon dioxide to form calcium carbonate and water. So this is the first part of this reaction. So actual example of combination reaction is this one only. This is the application of that, because this is not a combination reaction. If this was combination reaction, we would have got only one product, but here it is not the same. So this is the combination reaction. This is only an application of that combination reaction. Now we will see a few more examples of combination reactions. We already learned calcium oxide reacting with water to form silicate lime or calcium hydroxide and heat. Now combustion of coal and the combustion of hydrogen are the two more examples given in your textbook. But I have added a few more examples for you to just understand, because you will familiarize with the more compounds and balancing and all. So combustion of coal means if you burn coal in oxygen, coal is nothing but carbon which is in solid form. You combine with oxygen, so that's a gaseous form. What will you get? Carbon dioxide, which is another gas. And the same way, water formation, combustion of hydrogen, or if you burn hydrogen in oxygen, what do you get? Water. So hydrogen is in gaseous form, oxygen also in gaseous form. Initially water will be produced in vapor form, then we cool down it to form the liquid. So here 2H2, because to balance it, now 2H2 plus O2 gives 2H2O. Next, these examples are just for your information, no need to by heart. Formation of iron sulfide. Iron is a Fe, which is a solid, sulfur is solid, we get FeS, that is also another solid. Combination between ammonia and hydrogen chloride gas. Ammonia is a NH3, okay? NH3 is ammonia, NH4 is ammonia. You will come across ammonia also, so you should learn, familiarize. NH3 is ammonia, which is in the vapor form we are taking here, and the HCl also in the vapor, hydrogen chloride gas. When they both combine, we get ammonium chloride, NH4Cl, which is also a solid. Then we are talking about formation of iron 3 chloride, Fe, iron plus chlorine gives iron 3 chloride, FeCl3. The iron is a solid, we know, chlorine is a gas, and iron 3 chloride is a solid. Then last is a nitrogen dioxide formation. First we take nitric oxide, which is NO. To the nitric oxide we are heating it with oxygen. So what will we get? NO2, which is a gaseous form. So all are gaseous forms. So all these equations, what is common? Right hand side you will see only a single product. So we can call these as combination reaction. So basically you remember three equations. CaO plus H2O gives CaOH twice. Second, C plus O2 gives CO2. 3, 2H2 plus O2 gives 2H2O. Based on whether heat is absorbed into a reaction or released into a reaction, we can have two types of reactions. If heat is liberated during the reaction, then it is called a exothermic reaction. Exo means outside, therma means heat. Whereas some reactions, they absorb heat, or we have to provide energy in the form of heat or electricity or sometimes light, so that the reaction can happen. Until and unless we give energy or heat, it will not happen. Such reactions which take up heat are called a endothermic reaction. Endo means inside, therma means heat. Okay, so when we learned about combination reactions, the first experiment or the first reaction we studied was calcium oxide and water combining to form calcium hydroxide. Their heat was liberated out. So what kind of reaction is that? Exothermic reactions. So some of the combination reactions are exothermic reactions. So we will learn some more examples of exothermic reaction to understand what are exothermic reactions. So burning of natural gas. Natural gas means a methane. Methane formula is CH4. Methane. Okay. So this is in a gaseous form. So when we are combining methane with a burning. Burning means it is with a oxygen gas. What will you get? Carbon dioxide and water. So both are in gaseous form. Is it balanced? So we will see here. First we will start with the carbon. Here 1. Here also 1, okay. Next oxygen, here 2, here only 1, 2 and 1, 3. So we will make 2 here, here also 2. So now it became 2 into 2, 4, here also 2 plus 2, 4 it became. Now hydrogen, total 4 are here, here this time 2 into 2, 4. So now it is balanced. Methane, that is a CH4 gaseous form, combines with the 2 molecules of oxygen to give carbon dioxide and 2 molecules of water. Another example of exothermic reaction is a respiration. During respiration, what happens? As we learn in life process chapter, first when we eat the food, that is complex carbohydrates or proteins and fats, they are first broken down into simplest forms. So carbohydrate becomes glucose in our body or the intestine. Then it is taken by our blood to different cells. On reaching the cells, the oxygen also will reach the tissues or the cells, and using the oxygen, this glucose is broken down. So the formula of glucose is C6H12O6. This is glucose. Glucose is in aqueous form because it's in dissolved form. It is reaching the tissues through blood. So we can write aqueous. The same way oxygen coming from the lungs is also dissolved form. So it is in an aqueous form, not like gaseous form we are getting in our body. Then what do we get? Carbon dioxide plus water plus heat and light. Heat and energy. Okay, so here also heat is liberated out. There is heat. So C6H12O6 plus O2 gives CO2 plus H2O plus. See how to balance this equation. Here we can see carbon is 6. Here also carbon is 1. So we are writing 6 carbon. Then what happens to oxygen? Here it is 6. Here it is 2. 6 plus 2, 8 only. But here oxygen is 6 into 2, 12. 12 and here 1. So if you make here 6, you will get 12. But another 6 is left. So we can make it 6 here. So total will be here 6 plus 6 into 2, 12. 12 plus 6, 18. Here 6 into 2, 12. 12 plus 6, 18. So oxygen is now okay. Now let us see hydrogen. Here 12. Here 6 into 2, 12. So the balanced equation is C6H12O6 glucose plus 6O2 gives 6CO2 plus 6H2O plus. Finally, another example here, we don't have to write the equation, but just to know, decomposition of vegetable matter into compost. You know that when we are keeping the biodegradable waste in a soil, then what happens? It will eventually become part of the soil, merge with the soil. That is called a decomposition. So decomposition of vegetable matter, that also releases a lot of energy. So it is a kind of exothermic reaction. So these are the examples of exothermic reaction, which are the burning of natural gas or methane. Then respiration is an example of exothermic reaction, and decomposition of vegetable matter, another example of exothermic reaction. Today we learned combination reactions, what are combination reactions and the examples of combination reactions, and some additional examples also we dealt with. Then we saw that the first combination reaction that we studied was exothermic. So we also learned what are exothermic reactions and the 3 different examples of exothermic reactions. Hope you understood all these concepts very well. If so, please like, share and subscribe to my channel Biology My Passion. Thank you for watching.